Welcome to lecture series in physics. In this lecture series, we are discussing about gravitation, and in today's lecture, we will be solving some problems pertaining to gravitation, and we will be discussing some of the theories related to variation of g with altitude and variation of g with the depth, and we will be discussing the theory, the construction, working and principle of a compound pendulum and equivalent simple pendulum. Let us now solve this problem. I will read out the problem. How many times than the present speed would the earth have to be rotate about its axis in order that the apparent weight of the bodies at equator may be 0, and what should be the new period of rotation? So, to derive at this expression, so we have the formula. The formula is g dash is equal to g into 1 minus r omega squared cos squared lambda by g, where g dash is the value of acceleration due to gravity at a latitude lambda. So, at the equator we have the condition lambda is equal to 0, and therefore, what will happen to cos lambda or cos squared lambda? Cos squared lambda is equal to 1, and therefore, you substitute the value of cos squared lambda is equal to 1 in this expression, that is g dash is equal to g 1 minus r omega squared, cos squared lambda is 1, therefore, it is 1 minus r omega squared by g. So, we will calculate what is r omega squared by g. So, r omega squared by g is radius of the earth is 6.37 into 10 power 6 divided by into omega squared. So, omega squared is 2 pi divided by 86164, that is r omega squared by g. G is 9.8. So, when you substitute and simplify, this turns out to be 1 divided by 289. So, therefore, in order that the weight of a body at equator may be 0, the value of g should be 0, and if the new angular speed of the earth is omega dash, then I can write r into omega dash the whole squared divided by g is equal to 1. So, you divide this is you keep this as second equation, and what is the first equation? The first equation we got the result as 1 divided by 289. You keep this as first equation. Divide 1 by 2 or 2 by 1, we can have omega dash by omega, that is equal to 289. Therefore, omega dash by omega is equal to 289, or omega dash by omega dash by omega the whole squared is equal to 289. Therefore, omega dash by omega is equal to, it is root of 289, and when you release you get this as 17, Therefore, omega dash is equal to 17 omega. Hence, from this expression it is clear that the earth should have about 17 times the present angular velocity in order that apparent weight of the bodies at the equator be 0. Now, the earth makes one complete rotation in 86164 seconds. When the earth rotates 17 times faster, its new time period will be 86164 by 17, that is it will be 86164 by 17, that will be 5069 seconds, which means that it is 1 hour and 24 minutes and 29 seconds. And we will discuss another problem. I will read out the problem. If the earth were to cease rotating about the axis, what will be the change in the value of g at a place of latitude 45 degree, assuming that earth to be a sphere of radius 6.38 into 10 power 6 meters. G dash is equal to g into 1 minus r omega squared cos squared lambda by g, where g dash is the acceleration due to gravity at the latitude, and therefore, we have g dash is equal to g, that is g minus r omega squared cos squared lambda, where g is the acceleration due to gravity if the earth is at rest. So, therefore, we can have g minus g dash is the change in the value of g, that value is given by r omega squared cos squared lambda. So, we know that the radius of the earth r is equal to, it is 6.38 into 10 power 6 meter, and omega is 2 pi by 24 into 60 into 60, that is radians per second, and lambda is equal to 45 degree. Therefore, what will be cos squared lambda? So, since lambda equal to 45 degree and cos squared lambda is equal to, it is 1 by 2. So, we will evaluate what is g minus g dash. So, we should evaluate what is g minus g dash. So, in order to evaluate g minus g dash, you substitute the values, that is the radius of the earth is 6.38 into 10 power 6 into, it is 2 pi divided by 24 into 60 into 60 and into 1 by 2. So, when you simplify the whole expression, we get it is 0.0169 ms power minus 2. Therefore, if the earth were to cease rotating about its axis, the change in the value of g at a place of latitude 45 degree is 0.0169 ms power minus 2. And let us now discuss the variation of g with altitude. Let us consider a point P on the surface of the earth and let Q be the another point at an altitude h. So, let the mass of the earth is capital M and radius of the earth is capital R. Let g be the acceleration due to the gravity on the surface of the earth. Therefore, the force experienced by a body of mass m at P is equal to mg is equal to gmm by r squared. So, this is mg is the force, this is Newton's law of gravitation, this is force. And if we consider the force experienced by a body of mass m at P, then we can have mg dash is equal to gmm by r plus h the whole squared, where g dash is the acceleration due to gravity at an altitude h, and you divide this equation 2 by 1, we get g dash by g is equal to r squared by r plus h squared. So, we can have r squared, you take this here r squared as a common factor, therefore, 1 plus h by r the whole squared, and when you do this it is 1 plus h by r the whole power minus 2. And when you neglect the higher order powers of h by r, it turns out to be 1 plus h by r, or g dash is equal to g into 1 minus 2 h by r. This shows that the acceleration due to gravity decreases with increase in altitude. And for this is the diagram I can say, this is the earth you can say, and this is the center of point O, and this is some particular point. From this point you draw a line, and this line is P, and this is Q, and this at mass m, and this is at height h, and this is at r. So, this is capital M. So, this height, that is from here to here, this is the height h, and this is the figure. So, you can say this is the P point on the surface of the earth, and Q is another point on the at an altitude h. So, this is the altitude h, and m is the mass of the earth. So, this m, capital M is the mass of the earth, and r, this r is the radius of the earth, and g is the acceleration due to gravity. So, based on this diagram, we show that the acceleration due to gravity decreases with increase in altitude. So, let us now solve another problem. I will read out the problem. How far away from the earth does acceleration due to gravity become 1% of its value? So, this is become 1% of its value at the earth surface. Assume that the earth is a sphere of radius 6.38 into 10 power 6 meters. So, we will solve this problem. The acceleration due to gravity on the earth surface is g is equal to gm by r squared. So, the acceleration due to gravity on the earth's surface. I repeat, the acceleration due to gravity on the earth's surface is g. We already derived, that is equal to, it is gm by r squared. And similarly, the acceleration due to gravity at a height h is equal to, is nothing but g dash, and this g dash is equal to gm by r plus h the whole square. So, we know the value of r is 6.38 into 10 power 6 meter. Therefore, substituting we have g dash is equal to, it is 1 by 100 of g. Therefore, g dash by g is 1 by 100, and we will calculate what is h. So, in order to calculate h, we have g dash by g is equal to r squared by r plus h the whole squared, or it is, what is g dash by g? G dash by g is, there is 1 by 100, that is equal to r squared by r plus h the whole square, or when you simplify it further, we will have 1 by 10 is equal to r by r plus h. So, when you simplify it further, 1 by 100 is r squared by r plus h the whole square. Therefore, 1 by 10 will be r by r plus h. So, therefore, what is h? From this h, we can calculate it is 9 r. Therefore, when you substitute 9, what is radius of the earth? The radius of the earth is 6.38 into 10 power 6. When you substitute, you will get the answer as 5.742 into 10 power 7 meter. So, therefore, how far away from the earth? So, the distance is 5.742 into 10 power 7 meter. Let us solve another problem. I will read out this problem. A pendulum that beats seconds on the surface of the earth is found to lose 10.8 seconds per day when taken to a top of a hill 800 meter high. So, what is the radius of the earth? So, in order to solve this problem, let us say, let capital M be the mass of the earth and let capital R be the radius of the earth. Therefore, the acceleration due to gravity on the surface of the earth can be calculated as, in order to solve this problem, so we know that g is equal to, the value of g is g m by r squared, and let g dash is the acceleration due to gravity on the top of the hill. On the top of the hill, then g dash is equal to g m by r plus h the whole square. So, therefore, we will calculate what is g by g dash. So, g by g dash is equal to r plus h by r the whole square. Let t and t dash be the periods on the earth and on the top of the hill. Therefore, I can write g by g dash is equal to t dash by t the whole squared. Therefore, we have t is equal to 2 seconds and t dash is equal to, we have t is equal to 2 seconds and t dash is equal to, it is 86,400 divided by 86,400 minus 10.8 into 2. So, that will give rise to 86,400 divided by 86,389.2 into 2. So, therefore, t dash by t the whole squared is equal to, it is 86,400 divided by 86,389.2 the whole square. So, therefore, r plus h by r is equal to 86,400 divided by 86,389.2. So, that will give rise to 1.00012. Therefore, r plus 800 by r is equal to, it is 1.00012. Therefore, from this we can calculate what is r. R is 6.66 into 10 power 6 meter. So, therefore, the radius is 6.66 into 10 power 6 meter. And let us now calculate or derive an expression of variation of g with the depth. Let g and g dash be the values of acceleration due to gravity at a point p and q respectively. So, let us consider this is the surface of the earth, and at p let the acceleration due to gravity be g, and at q let the acceleration due to gravity be g dash. So, at p what happens at this point p, the whole mass of the earth is attracted by the body. Therefore, according to Newton's law of gravitation, I can write mg is equal to g mm by r squared. So, where m is the mass of the body and capital M is the mass of the earth and r is the radius of the earth. At q, the body is attracted by the mass of the radius r minus h. Therefore, mg is equal to gmm dash gm dash m by r squared, and since the mass is volume into density, I can write 4 by 3 pi r cube into rho, and m dash at a height h is 4 by 3 r minus h the whole cube into rho, where rho is the mean density of the earth. You divide this equation and this equation, first equation and second equation. When you divide this equation, I get g dash by g is equal to m dash by m, that is equal to, when you simplify 4 by 3 pi into r minus h the whole squared into rho by 4 by 3 pi r cube rho into r squared into r minus h the whole squared, it will turn out to be r minus h by r, that is equal to 1 minus h by r. Therefore, since this is g dash, therefore, g dash is equal to g into 1 minus h by r. Therefore, the acceleration due to gravity decreases with the increase of depth. Let us now summarize what we have learned so far in this session. In this session, we solved some problems on gravitation, and the problems related to, that is acceleration due to gravity with the latitude and rotation of the earth, and we discussed some of the theories based on variation of acceleration due to gravity with altitude, and we derived an expression for variation of acceleration due to gravity with the depth. Thank you.